thank you everybody to be here. Also, a big thank to the staff. They did an amazing work. Today I'm going to present privilege escalation in Azure Machine Learning. I know that now you hear Azure, you want to run away, but please stay with me. Now, this presentation is not super advanced, so there are no kernel exploitation or Windows API call, but it's not a basic one neither, so you need to know a little bit of Azure storage account, what is a managed identity, what is a role. I'm not going to explain all of this in details. But you don't need to know anything about Azure Machine Learning itself. The presentation is going to be divided in two parts. In the first part, I'm going to give you the base knowledge about what is Azure ML. In the second part, we are going to do the hacking stuff, okay? So, who am I? I'm a penetration tester. During my free time, I enjoy exploiting Azure and finding vulnerability in Active Directory. I published a few articles last year about Azure Arc, Azure Application Proxy. You can find this on my blog, xybytes.com. Also, if you want to keep in touch, go on Twitter, and I'm open to collaboration. So why Azure Machine Learning? Well, because we are in the middle of the AI revolution. AI is completely reshaped the world from biology, medicine, and of course the cloud providers are follow the trends. Azure is no different, and so it developed Azure Machine Learning to allow data scientists to develop Azure lifecycle. So what is Azure Machine Learning? It's a cloud platform designed to manage the entirely machine learning lifecycle. So you can do many things inside, okay? It's one packet with many features. You can, for example, explore and prepare datasets. You can import your dataset, clean the dataset, go deep on the dataset. So you can do all this operation. You can deploy automatically your model in web endpoint or containers or as you wish. So there are different compute methods that you can use. You can have notebooks. So imagine that you are developing as a data scientist. You have Jupyter notebooks online. You go to the platforms. You create a Python scripts, and then you start working on this, right? So it's very interactive. And of course, you can automate. There are some features that allow you to create models without coding. So there are many, many things inside here. And it's Azure Machine Learning is complicated, okay? It's complex. There are a lot of things happening in the backend with the application inside, Azure storage, and other stuff. So a warning before we move on. Azure Machine Learning is a work in progress, okay? So it's possible that the things that I'm going to say today are going to change in a couple of months or weeks. When I was testing Azure Machine Learning, every week, new button, new feature, the workflow was different. They were constantly updating the platform all the time. They drive me crazy. So be careful. It's possible that things work now, in 2 weeks they don't work anymore, okay? So let's go understanding a little bit of the basic. So when you create Azure Machine Learning, the first thing that you do, you create a workspace, okay? In the workspace is your dashboard when you work with all the process here. So where you can create notebooks, you can run compute instance, you can import models, and you have a GUI like this one, right? This portal, and you have different features, notebooks, automation ML, data, jobs, pipelines, and you can scroll down and click what you have to do, right? But when you create a workspace, what's happened under the hood is other services are created. Okay, these other services are connected to the workspace, a storage account, an Azure container registry, application inside. So all of these things are created together with the workspace and also the key vault. There are some default roles that you can give. There are Azure ML data scientists. This role can perform any actions in Azure ML except creating and managing machines, but it can create notebooks, it can import data sets, turn on, turn off the compute instance. you have the Azure ML compute operator that is basically the sysadmin for the ML, Azure ML, so you can create, manage, delete, access resources, computer resources. And then you have the classic reader, contributor, owner, AD role. So there are different kind of compute instance that you can have. There is the compute cluster, the Kubernetes, the attached machine, and there is also the classic compute instance, right? I only explored the last one, the compute instance. The compute instance are compute resources in Azure ML, okay? So you can run a new, create a new compute instance in the platform itself without having to use external resources for it, okay? This is what you can see here is an example. I just open a notebook, and you can choose to develop this code, and then you select your compute instance on the right, and then you can run these notebooks, okay? You can also access to the shell, to the compute from this dashboard. Now, the interesting things here is that you can assign a compute instance to a specific user, right? So each user is going to have his own compute instance. But each one of these compute instances, they have the same file share attached, okay? And this file share attached is where all the clouds files are stored. So all your notebooks, all your data are there and are shared between the users. So each user has access a different compute instance, but they share the same files. Okay? So if I code something, a notebook, and I put in the cloud, the other user, the other data scientist can access the file. Okay? So if you are the code credential, they are there, everybody can see. Okay? So this is very important to remember. This is an example. I got into one of the compute instances. You can see there the directory cloud files. This is the directory where all these shared files are stored. Okay, so if you go in this directory, you find all your shared file between you and everybody else that are using Azure Machine Learning. Okay. So you can already see a little bit of problems here because, okay, you want to be careful what you do there, what you put, which files are there, which are not there, because they're not private, not completely, okay? So you have to trust your team, you have to trust who give access to Azure ML. So all of these files, all of this stuff, the train models, the notebooks, the bash scripts, whatever you have there are stored in this storage account, okay? So the storage account is connected to Azure ML, and it has a file share and a blob storage, right? In the file share, you find, for example, the notebooks, you find the different scripts you have on the machines, and on the blob storage, you have the experiments, the jobs, the trained models, the pickle file. So you have everything here, okay? And as I explained, this share is mounted on each compute instance. So each compute instance can retrieve these files, okay? Again, this is an example of notebooks, a file, and this file is inside the file share, okay? And just a reminder, Azure File Share has credential-based authentication, but it doesn't have identity-based authentication. So you just need a storage account access key to access the file share. So keep in mind these things too. So how this feature can be exploited and what can happen if an attacker wants to do a privilege escalation and to access your Azure Machine Learning. So one method that I found that I call it the startup scripts. So there is a features that allow you to create a startup script that's going to be run every time you reboot, or create a new compute instance, okay? So you create this startup script. This startup script is stored in the file share that I showed you before. And every time this computer instance starts, the startup script is started, right? So usually are bash script, and there are scripts used for different operations, right? Update, install packages, and things like that. So this is an example, right? There is a default script, is in the notebooks. Every user can access this, right? And this script does something, right? It install package, whatever. So, but what's happened if I have access to the storage account, to the file share, but I don't have access to Azure Machine Learning? So, because this script and all of the notebooks are in the file share, even if I don't have permission to the Azure Machine Learning, I can still modify them. So imagine this scenario, okay? You have an access key for the file share because you compromise another user. You don't have permission to escalate to Azure Machine Learning, but you have permission to modify the files. So what you can do, you can explore the file share, find your startup script, inject your malicious code, and simply wait that the user turn on the machine. And because this compute instance is quite expensive, usually they have a schedule. So they usually turn off every 2-3 hours. When you don't use it, then they turn on again. So they turn off quite frequently. Okay. So and this is the scenario, right? This is not completely new things in Azure. We have these problems with other services like Azure Function and other stuff like that. So when you can compromise the storage account and then you escalate, right? So it's not completely new things. So the attack step. Imagine that you have a user, in this case, Hallie. She has no permission in Azure Machine Learning, okay? But Hallie has access to the file share. So she found a startup script. She injected a malicious code, a reverse shell in this case, but you can inject whatever you want. And then when the machine is turned on, the malicious code is triggered, and now she has a shell, okay? And this is an example. I retrieve access token for the machine, because these computer instance, they also have a managed identity, okay? So you can use this to escalate to other service, okay? Because imagine that the data scientists want to connect to some key vault or some other stuff. So they use managed identity to connect this compute instance to other Azure resources. So now from compute instance, you go to other resources. So you start from the storage account, you go to compute instance, and now you move laterally in the cloud, okay? Yeah, I have a video POC. I think I have to click on it to start it. Yes. So in this case, Ellie has no access to Azure Machine Learning. Sorry, you cannot access, right? But he can access the storage account. You can do it with the Azure command line tool if you want, so you don't have to use the portal. But I wanted to show you a little bit better. So this is the startup script. Right? So now I'm going to open a listener of my machine with Netcat. And I'm going to use NGRAW to tunneling because I didn't have a public API at the time. And then I simply create my own startup script, right? I overwrite the script. This is simple bash reverse shell. Very, very simple. Right? And this is the shell, right? The reverse shell. Now you overwrite this file, right? Now this is the new startup script. Now imagine that, show you, it's different. This is the notebooks. And you start one compute instance. Okay, so this is another user that is using Azure ML, okay? And now you get a reverse shell. So this is, Okay, so this was the first method, okay, the startup scripts. You might wonder, can I do the same things with notebooks? Yes, you can, potentially. It's a little bit more tricky because with notebooks, you have to do a little bit of social engineering because data scientists use notebooks, they can see it. So yes, you can inject Python code there, but you need to hide it. You need to be much more settled there. The startup script is more direct because, right, it's going to start every time the machine is turned on. Another way you can do is, I told you there are notebooks, there are scripts, but there are also compiled models, trained models. So there are pickle file, right? And this pickle file, different from the notebooks and the startup scripts, they are stored in the blob storage, okay? And the thing is, you can inject malicious code into this file. So you can access the storage account, access this file, inject your malicious Python code, and every time the model is deployed with Flask, it can be deployed in the containers, in a web endpoint, your malicious code is triggered with the model, right? This is a tool that you can use to inject malicious code in the pickle file, flicking. So the process is the same, right? You get the model, the pickle file. They are called model.pickle. There are different, you can find usually different experiments. So you download your model, you inject your Python code into the pickle file, and you re-upload, right? You override the file. And now every time that this model is deployed, your malicious code is triggered. In this case, I use an Azure container instance, so very easily. The Flask started, the model is executed, and now I have a reverse shell, like before, with a managed entity, and so I can, with an access token that I can use to move laterally. So this is another way, another things you can do. It's a little bit more dangerous than the startup script because this model can be deployed everywhere, right? You can take the model and take away from Azure and deploy on AWS, on other services. So they are not only affect the compute instance, but they affect every places where you deploy them, okay? Okay, so another things that I want to show you is, I show you how is it possible to go from storage account to Azure Machine Learning, right? But what you can do if you compromise a compute instance, what you can do from there? You can do the opposite. You can go from compute instance to storage account, so you can get a storage account access key. Okay, this is not my new things, was already discovered by Nitesh, but I dive deep more into this. And so this is a little bit more complex than what I showed you before, but if you follow me, we will understand. So there is a process in the compute instance that is called dismount agent, okay? And this is the agent that mount the instance, the file share, sorry. So every 100 seconds is going to check if the file share is mounted. If it's not, it's going to mount it in the compute instance, right? So basically, this is the process that takes care of check and mount. This daemon has to authenticate, okay, because he has to retrieve the storage account access key to mount the file share. The way that it's going to do it is going to connect to the XSD endpoint, okay? How it's going to do it is going to use a private key and a certificate, okay? This private key and certificate are stored on the compute instance, okay? So you can find this directory here, the key, the PEM file, and the PFX file, okay? So you are an attacker, you are here, and so what you do, you take these two files, right? Because with these two files, you can basically connect to the XSD endpoint and retrieve a few things, okay? There are mainly 3 methods right now. One is get workspace, the other one is get ADD token, the other one is get workspace secret, okay? So with the first methods, you retrieve some information about the workspace. With the second one, you retrieve the managed entity of the compute instance or the access token. So you don't have to be on the compute instance anymore. You can simply get the certificate, get the private key, and then connect to the endpoint, and you get the access token for the compute instance. So if you lose access to the compute instance, no problem anymore. I can get my access token. So this is interesting for persistence. With the last method, you can retrieve what is called the account key JWE. What is this stuff? This stuff is basically the encrypted storage account access key. Okay, so inside these things, you find the storage account access key. So what I did was, okay, I took this PEM file and certificate and private key. I generate a pfix file. I import it into Burp, and now I can authenticate, right? It's a client-side certificate authentication. This is the first method, for example. I connected to the endpoint, to the XSD endpoint. I use the get workspace method, and I retrieve a bunch of information about my workspace, okay? This is for enumeration, right? This is another method, is get ADD token. With this, you get the access token for the identity of the compute instance, and you get the token there. Okay, so now with this token, you can authenticate in Azure and move to other system if this compute instance can access other stuff. And here is the last method, get workspace secret, where you get the account key JWE. Okay, now this is encrypted for now. So you have to decrypt it before you can access the storage account access key. So how you do it? This is like a matryoshka. You have the first private key, it's called cluster private key, that is decrypt the second key, this encrypted symmetric key, that is going to decrypt the JWE. And when you decrypt the JWE, you get the storage account access key, right? Where are these two keys? These two keys are in an environment file. You can find in the same compute instance right there. You can get the two keys. You can export them, right? And then you can simply decrypt the first key, the second key with the first one, and with the second key the JWE, right? You can do it with a simple Python script, use JOSE library, right? So in this case, I decrypt the encrypted symmetric key, the first one, and then I use the decrypted key to decrypt the account, the JWE, right? So as you can see here in the first screenshot, the first one is the decrypted key. The second one is when I decrypt the account key, that JWE, and you get the storage account access key, right? So the second string you see is the storage account access key of the storage account access key connected to the Azure Machine Learning, of course. And now with this storage account access key, we can use Azure command line tool and connect to the storage account, okay? So from one compute instance, we compromise the storage account now. Now, this works until 3 weeks ago. Then I open a pull request to Microbuster project because I developed an automation script to automate all of this process, all of these things I show you. And 2 weeks later, Microsoft fixed everything. So what is the situation now? Now the pfix file is not there anymore, and the hard-coded key are not in the environment file anymore. Okay. I think that is still something there because the compute instance needs to mount the file share. So, and to do that, it needs to authenticate. So it has to do something to retrieve the storage account access key. So they changed something. I think the problem is still there. I didn't have time to dive deep into these problems, but I think there is a similar concern, even if these two private keys are not there anymore. We have to discover where are they now and what they did with the backend XSD API. But I think there is potential here still. Now, so we go from storage account to compute instance to storage account. But you might wonder, okay, I'm inside Azure ML, Chris. What I can do now? You can harvest in credential. If you think that you can access only Azure Machine Learning things, you are wrong. because Azure Machine Learning has a lot of credentials for other services, okay? There are two ways to store secrets in Azure Machine Learning. With the first way is the workspace connection. The second way is the key vault. The key vault is more secure. This is what Microsoft advised to use. Nobody use it. Everybody use workspace connection because it's easy to use it. And in using workspace connection, you can insert your own credentials, okay? It's inside the portal. So you go to the portal, you can create a new secret, and then you insert your API key, okay? So everything can be here, okay? From API keys to S3 buckets. So you can also cross the boundary of Azure and compromise other systems. The interesting part is when you go to this part of the portal, you notice that you cannot read the secrets. Okay, from the portal you cannot read the secret; they are hidden by asterisk. But the secrets are still accessible from the backend API. So yes, you cannot read the secret, but you can connect to the backend API, and you can access the secret that you want to see. Okay. So this is a reminder. When you give access to data scientists to Azure Machine Learning, they also have access to all the secrets stored there. Okay, so they can access your AWS, if you have AWS access key. They can access OpenAI key, whatever is there, right? So they can move to other parts of your infrastructure, of your environment. So this is very important. Yes. So automation, more automation. Right now there are two scripts. The first script was developed by Carl, the owner of the Microburst project. The second script was developed by me. With the first scripts, you can grab all the credentials that are in Azure ML. Okay. With the second one, you can fetch all the important data like jobs, experiments, compute distance, information, work secrets. So you can use these two scripts to enumerate Azure Machine Learning. Of course, you need to have access, okay, with the right permission to do it. But it can be used to grab information and see if you can move laterally somewhere from there. So a little bit of advice what you can do to improve security in Azure ML. One advice is use private endpoint. Okay, when you create Azure Machine Learning, you have a choice, as everything in life. You can choose the public endpoint, so everybody can access it, or you can choose the private endpoint. With the private endpoint, of course, it's more secure because you need a VNet with a private IP to access this. So my suggestion is to use the private endpoint if you don't need the public exposure. This was one advice. The second thing is monitor the cloud, as always. Look what's going on there, right? Monitor the cloud if there are new compute instances, if there are new secrets in the workspace, jobs, pickle files. Okay, so monitor all of this stuff. Rotate storage account key regularly, so you can rotate the storage account key regularly. This is a good advice. Review the Jupyter notebook. Okay, this is another thing. Review these Jupyter notebooks because you don't know what is there. Okay, it's not just because attackers can compromise them. It's because the user can hard-code credentials too, right? So they can do things. And of course, enforce the less privileged access to minimize the risk. Okay, if someone is not a data scientist, you don't want to give full access to the platform. Okay, you want to give partially access, read-only access based on what you have to do. Okay, so always think that from Azure Machine Learning they can move to other part. Okay, so you're giving them access to many things usually, not just Azure ML. So that's all. There are any questions? Yes, that seems so.
Okay. In the back, of course. Mike. Thank you.
Hi, just to iterate on the workspace versus key vault thing. You mentioned that the key vault is more secure.
Yeah.
Can you just explain a bit in what way? And is it possible, for example, for the managed identity to gain access or have the permissions to list the secrets in the key vault the same way as a user would be to list the connection secrets?
Yeah, it's possible. You can assign permission to access from the compute instance to the key vault. Yes, you can do it. It's a little bit more secure because you can use role-based access control. So you can say, okay, I want just these two compute instances to access the key vault. Okay, so with managed identity, they authenticate and can access the key vault. But I don't want to give other data scientists this permission. With workspace, as soon you are with workspace secret, as soon you are in the dashboard, you have all the secrets. So you have no way to enforce granular access control. But this is something that you can do with Key Vault, right? But yes, what you're saying is correct. If you compromise one compute instance, and this compute instance has to access some secret in the Key Vault, now you have access to the Key Vault, right? So yes, it's possible to move laterally like this too.
Yeah, so essentially, once you have a compute instance under control, all the secrets are exposed as expected, but the portal is somewhat secured, right?
Yeah. Because these compute instances have managed identity. You can treat them like a Azure VM. You are in an Azure VM, so now the Azure VM can access other resources, and you can move laterally, right?
Great, thank you.
Welcome.
Thank you for the question. Any other? Okay, thank you, Christian. That's it for now.
Thank you.